Number 67, integrated concepts. Letter A, an immersion heater using 120 volts can raise the temperature of a 100 gram aluminum cup containing 350 grams of water from 20 to 95 in 2 minutes. Find its resistance, assuming constant. All right. So first thing, we know we're talking about heating things up and, it takes a certain amount of energy to do so. So why don't we calculate the total amount of heat energy required? That would be then equal to the heat energy required to raise the aluminum plus then the heat energy required to raise the water. We know then from the formulas of whatever chapter it was, 13, who knows, that this is talking about the mass of the aluminum, specific heat of the aluminum, and then the change in temperature of the aluminum, plus then the mass of the water, and I'm just going to leave it W. Specific heat of the water, change in temperature of the water. Okay, they're both changing by the same amount, so you could factor out the change. It doesn't matter. So I'm going to write delta T, of the objects, and then I'm going to have this plus then this term because I'm factoring out the common delta T. All right, so we know that the change in temperature is going to be final minus initial, so it's 95 minus the 20. And then now I got my mass of aluminum, which they told me was, 100 grams. So it's 100 over then 1,000 because we need that in kilograms, multiplied by the specific heat, which is 900, plus then the mass of the water. They said 350 grams, but, we need that in kilograms, so that's divided by 1,000, multiplied then by the specific heat, so 4186. You might be using 4184. I use it sometimes too. Depends on the starting temperature. Technically, the specific heat of the water will change over the changing temperatures. So any calculations we do, whether you use 4186 or 4184, they're both wrong. So don't worry about it. So now what we're going to do, if you want to figure out how to do that, then we got to do calculus. So this is going to be 95 minus the 20. So 75. And then what we're going to do is take that now and multiply it by essentially 0.1 times 900 plus 0.35 times 4186. So here we're going to have a total value of I did division. I was looking at this. I'm like, yeah, that sounds like a really small, tiny value. So 1 second. All right, so 75 times. There we go. So this is going to be 0.1 times 900 plus 0.35 times 4186. So here's why you want to, and I think I actually plugged in 4184 in that case. So you know what? I'm going to use the 4. So this is now going to be, and again, like I said, they're both going to be incorrect. So just depends on, which way you want to be incorrect. 1.17, I guess. So 1.17 times 10 to the 345, and that's going to be in joules. So that is then the amount of heat energy that's necessary. So now it wants to find the resistance, right? So we have to somehow now take energy and relate it now to, resistance or whatever. They also give us a time. Ooh, wait a minute. Energy per time? Is that power? Sure it is. So now what we need to do is we need to then take our power formula that relates resistance and voltage. Here it is on the upper right. Power is going to be equal to voltage squared over resistance. Simply cross multiply that resistance. And now here we go. Remember, decompose the power into energy per time. We've seen that now operate in the past 50 problems. So that's now energy over time, and now we can plug in our values. Your voltage is 120. Your energy here we just calculated was 1.17 times 10 to the 5. And then divide that now by the 2 minutes, but you need that, remember, in seconds, so that's going to be 120 seconds. And bada bing, bada boom. So now 120 squared, divided then by parenthesis 1 point, let me just take that exact value, and then divide it then by 120. And that looks good. So there's about 14.8. So this is 14.8 ohms. That's reasonable. Okay, sounds right. And like I said, we're both going to be off depending upon what value you use, and they're both technically wrong. So letter B, a low resistance would shorten the heating time. Discuss the practical limits. Think about that and let me know. All right, we'll talk to you later. Take care. I'll talk to you later. Be well. Subscribe. Bye.